Third scenario, if you save $1,000 per month for 5 years, what would you have saved up? The annual interest rate is, again, 6%, and we sketch cash flows. Now, this one's tricky because what we've got now, a lot of cash flows. It's $1,000 per month. So what that means is we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? We'll have 12 payments in year 1, and likewise, we'll have 12 payments in year 2. So you can visualize that we would have, over the course of the time, we would have 60 payments. The next tab over. So it's $1,000 per month, 1,000, but we have it for 60 months. So copy that, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way out there to 60 months, right? And then we'd have to have a factor, which is equal to plus 1 divided by open parens, 1 plus the interest rate, lock it, to the power of the number of months. This rate has to be divided by 12 because it's a monthly rate. So it equals 0.05 divided by 12. So that would be the factor, and we'd have to copy this out way out there, somewhere out to 60 months. And we could do this and multiply the PV factor times the cash flow out for 60 months, but that would be quite tedious. So here's where there's a clear preference. Do not do 60 months and 60. So we use this one, and actually I'll just write no the payments, want the FB. Okay. So what is the payment? 1,000. Or I'm sorry, what is the rate? Again, it's monthly, so it equals or plus 0.06 divided by 12. And then what's the number of periods? 60, right? 60 months is 5 years. The payments, $1,000 a month. And let's have us put out the money. We're going to save $1,000, so we're going to take out of our pocket $1,000. And the present value, nothing. It says 0 at this point. And the question mark is here, the future value. So let's go with future value equals FV, open parens. Again, this is going to get boring. The rate, but remember it's a monthly rate. So it's the annual rate divided by 12. The number of periods, 60 months, not years, comma. Then what is the payment amount? $1,000 negative. We're paying out. What is the PV? There's no additional PV. And then what is the future value, or type rather? We'll take the default, close parens, enter. And we'll end up with a number of 69,770. So if we put $1,000 a month in the bank for 5 years, over that time period, it would accumulate to 69,770. All right, so that's the answer to scenario 3, 69,000. And notice that we could have done this all the way out to payment 60 or month 60, but that's quite a bit more work than simply doing this calculation right there. Okay. All right, so next scenario is PV and an annuity. So would you rather have $1.5 billion over 29 years, which is the equivalent of 51.7 million, or I guess it's a different number, or $750 million today? So we actually have a choice. So that's why there are 2 sketches here, 2 graphs. Would you rather have 51 million a year for 29 years? So the first scenario is you get all these payments. So we get 29 years of 51.7 million per year. Or would you rather have a massively large lump sum here now? Okay, so that's the choice. All right, so that's pretty ugly, I must say. So when we move to the tabs, we're going to use, again, since it's so many years, I'm not going to bother with laying out 29 years of columns. So I'm going to go right to the case of a PV. So here, I'll just write here, we know the payments, and we want the PV. Okay, so the rate is 6%, 0.06. The number of periods, 29. The payments, now we do have payments, 51.7. And the PV, that is our question mark. And so this is the one that should be yellow. And then the future value, there's no other payments because we're happy to just get 29 years worth of 51 million a year. So now let's solve for it. So equals PV, open parens, what is the rate? 6%, comma, what is the period? 29 years, comma, what is the payment? $51 million, comma, is there any subsequent payment? No, close parens, enter. And the answer here is $702 million. Now you recall that the question was, would you rather have 750, right, versus 702? So this is really the choice. And if these are our choices, I'd rather take the 750 now. Right? So here we have, what's the present value of the cash flow to us? 702. What are they offering me? 750. I'll take the 750. We should all be so lucky to get one big check for $750 million today.